Alright, hello chemistry nerds. This is going to be the video going over the practice exam you guys have worked on for the past couple of days. Okay, so we start here with number 1. Given this balanced equation, 2H2s plus O2 yields 2H2Os. We're looking for the total mass of water formed when 8 grams of hydrogen reacts completely with 64 grams of oxygen. Okay, so for this one, we have to follow the law of conservation. And what does that mean? We have to have the same number of atoms, charges, and total mass on both sides of the equation. Okay, so looking at our equation right here, so 2 yields 2H2Os. We start here with 8 grams of hydrogen with 64 grams of oxygen. Both of those together make 72 grams on the left side. So on this right side, we should also end up with 72 grams of water. And since water is the only thing there, so that means all of that mass is going towards water. So the answer is choice 4. Number 2. What is the gram formula mass of FeNO33? So it's iron nitrate. So let's break it down into each of the elements. So there's 1 iron, 3 nitrogens, and 9 oxygens. This one is 14. Iron is 56. Multiply across, and you add them up. This one's 42. This one is... And you add all this up. 144 plus 42 plus 56. And you get 242 grams per mole of iron nitrate. Number 3, the gram formula mass of NO2 is defined as, so gram formula mass is the same as molar mass, the mass of 1 mole of NO2. Alright, number 4. A compound has a molar mass of 90 grams per mole, and the empirical formula is CH2O. What is the... This question doesn't even really make sense. It hasn't even a complete thought here. Anyway, what is the molecular formula of this compound? Alright, so first let's start with our empirical formula, CH2O. So it's gram formula mass. There's 1 carbon plus 2 hydrogens plus 1 oxygen. 14 plus 16 is 30 grams per mole. Just for the empirical. The empirical is a reduced form of the molecular, so we're going to take our bigger number, divided by our smaller number, and we get a factor of 3. That means the molecular formula is 3 times greater than our empirical. This becomes C3H6O3. Okay, so number 5 now. We have to figure out which compound has the 42% composition of chlorine. So Cl's atomic mass is, let's approximate it to 35 grams. And so we take each of these choices and see which of them comes out to 42%. So if we do this, so 42% is about less than half. And so looking at these, which of them fall under less than half? Closest one would be choice 4. And just to verify with the math, 35 divided by 84 times 100 equals it approximates to 42%. Okay. Number 6. The percent composition by mass of nitrogen in NH4OH is equal to what? So here we're looking for a numerical setup. So percent composition is equal to the mass of the part. There's only 1 nitrogen in there, so 14 grams is the part over the whole of 35 times 100 for the percent. And so we look for the choice that best fits this, and that is choice 2. Number 7, which equation represents a single replacement reaction? So we're looking to see what kind of reaction represents a couple being broken up by a free agent. And then that free agent coming in to steal that partner. And looking at these, choice 2 fits the bill. Now I'm going to label these other reactions. Number 1 shows a swap, like a partner swap, so that's a double replacement. Number 3 is a decomposition. And then number 4 is a synthesis reaction. So decomposition meaning one breaks down into multiple substances, and synthesis is taking multiple substances, combining them into a single substance. Okay. Number 8, this reaction is classified as what? So looking at this here, Ag was attached to NO3, and looking at after the reaction, NO3 is with a new partner, as is Ag. So this is kind of like a couple swap, and we get a double replacement. Number 9, given the incomplete equation representing a reaction. All right, we're figuring out the coefficient of O2. So let's look on the right side and figure out how many oxygens we have here, assuming that everything else is balanced. So here we have 24 oxygens, and here we have 14. Altogether, that equals to 38. So how do we fit 38 oxygens on the left side? So we should put a 19 there. 19 O2s leads to 38 oxygens. All right, number 10, we have to correctly balance this. So let's go through this one by one. All right, let's start with copper. Copper seems to be good, 1-1 on both sides. Now looking on the right side, let's look at sulfur. Here we have 2 sulfurs on the right side, versus on the left side, we only have 1. So in order to match that, let's put a 2 right there. Okay, now let's look at hydrogens. Now we have 4 hydrogens on the left side. On the right side, there's 2. To make that even, we put a 2 right there, 4-4. Now let's look at our oxygens and double check if everything is set. So on the left side, we have 8 oxygens. On the right side, here, I'm going to break it down each. There's 4 here, there's 2 here, and 2 here, for a total of 8. So 8, 8 on both sides, we're set. Now this question is asking for the coefficient of CuSO4, so that's just 1. All right, number 11, this is a mole-to-mole ratio question. We're comparing O2 with NH3. So the way we could solve this is to set up a ratio of O2 to NH3. Next, we're going to go look at their coefficients in the reaction. There's 5 for O2 and 4 for NH3. Next, we look into what the problem is giving us. So for every 5 moles of oxygen, there are 4 moles of NH3 in this reaction. Now let's say we have 16 moles of NH3. How many do we need of oxygen? So we're going to cross multiply. 4x, this is 80 is equal to 4x, and x is equal to 20 moles. Number 12, our equation is balanced. We need the mole-to-mole ratio of NaOH to AlOH, aluminum hydroxide and sodium hydroxide. So it's 6-2, but we got to reduce this even further to 3-1, choice 2. All right, number 13, which compound has the highest percent composition by mass of strontium? So strontium's atomic mass, if you look at all 4 choices, they only have strontium once. Strontium is 88 grams per mole. So we're looking for percent compositions that's the highest. Now look here, we're dividing by the molar mass, the total. So if we want the highest percent composition, we need a molar mass that's as close to 88 as possible. And so we need something that adds very little to the overall composition. And looking at each of these elements here, oxygen looks to be the one that adds the least to it. Because if we actually do the math, this one is 104, this one is 120. This one's 158. And then this one is 342. The one closest to 88 has to be choice 4, strontium oxide. 14. Which equation shows a conservation of mass? So we're looking for a balanced number of atoms on both sides of the equation. And the one that fits that bill is choice 2. There's 1 phosphorus on both sides, and there's 5 chlorines on both sides. Number 15. Mole ratio of H2 to HF. So there's 1 of there and 2 of that, 1 to 2. All right, number 16. This is kind of like number 1. So determine the total mass of Cu produced when 1.08 grams of aluminum reacts completely with 9.58 grams of CuSO4 to produce 6.85 grams of aluminum sulfate. So based on conservation of mass, the total on both sides have to be the same. So on the left side, 1.08 plus 9.58 altogether gets us 10.66 grams. On the other side, we only have 6.85 as our known value, so 10.66 minus 6.85 will get us our answer. And that is 3.81 grams. That's our answer. Now, what is the type of reaction shown here? Here we have a free element and a compound. The free element comes in, breaks up copper sulfate, and takes the sulfate for itself, leaving copper by itself now. So this is what we call single replacement. Number 18, determine the total number of moles of oxygen react completely with 8 moles of C2H6. Another proportion, O2 over C2H6, O2 is 7, C2H6 is 2. We have 8 here, X over here. 56 equals 2X, X is equal to 28 moles. Okay, number 19, total number of moles in 80 grams. All right, so we use our formula, number of moles equals mass over molar mass. If you don't remember this, it's in the reference table. We have 80 grams, and our molar mass is 64.5 grams per mole. So 80 divided by 64.5, we should get a number bigger than 1. And it's 1.24 moles. Okay, so for number 20, we just have to balance this equation. No masses are needed. All right, so we got 1 zinc on both sides. Let's just put that for now. Now on the right side, we have 2 chlorines. To balance that out, we gotta put a 2 here for 2 chlorines each. Now we got 2 hydrogens. On the left side, already there's 2 hydrogens on the other side, so that's it. And that is it for this review video. All 20 questions done. If you guys want to review your content, make sure you check out the other videos on stoichiometry and balancing and reactions. Good luck.